Hello, guys. Back again here for chapter 3, objective number 5, and hopefully 6. We'll see how far I get. Okay, so I'm going to share my screen, and here we go with objective 5. Share that, and let's get that on the. Okay, well, we're going to describe the structures and functions of the cerebral cortex. Now, remember, the cerebral cortex is part of the forebrain. It's the kind of the outer structure of the forebrain. So we've talked about it a little bit before. So first off, one thing is that the cerebral cortex is generally thought of as being in two halves. You have your right hemisphere and your left hemisphere. And there you can see here, there's a big long kind of line in between them there, and that's called the longitudinal fissure. We'll get to that, I think, a little bit later on. But that divides the cerebral hemispheres. And you know that we have contralateral control, so the right side of our brains will control the left side of our body and vice versa. Well, they do communicate with each other, and they do so through a couple of different routes. And one is the corpus callosum, and that's that big bridge there. And then there's also a much smaller bridge below the two halves there called the anterior commissure. So they do definitely communicate there half to half. Okay, well, we can map out the cerebral cortex and by the outer covering of it, and looking at where it's convoluted in the sense that it's got some bulges, you know, in it where it looks like kind of like cauliflower, and then there's some grooves in between. And so what we call those bulges is gyri, or the singular is gyrus. And what we call the grooves are sulci, singular being sulcus. And then a really, really large groove, like I was talking about in the last slide, the longitudinal fissure is called a fissure. Yeah. Okay. So, duh. Okay. Then there are 4 lobes that we map out, and in purple there, or pink, we see the frontal lobe, and then in yellowish we see the parietal, occipital on the back of the brain, and then the temporal lobe there in green. Well, we're going to start with the occipital lobe right there on the back of the brain. You can see in this picture, and that is involved in vision. So that's seeing and interpreting visual information. There is contained the primary visual cortex. It's going to receive signals from the eyes. Remember, those signals first go to the thalamus, then out to the primary visual cortex. And if you get damage there, there's some interesting things that happen. For one, you're going to lose sight in the contralateral visual field. So meaning that if you get damage to, you know, the right side of the occipital lobe, then you're going to have a spot over here that you don't see anything. And so that's where you see that spot there. So we call that cortical blindness. And typically people with pretty bad damage, they'll see light, but they don't see any patterns. And if they have complete damage to the occipital cortex there, they don't have any mental imagery, which is interesting, meaning that they can't dream in visual ways. Now, typically people who are blind because of damage to their eyes, in which case they can still imagine an elephant, for example, and they can kind of see it in their mind. But people with cortical blindness do not even have that. They just don't have the mental imagery. Okay, let's move along to the parietal lobe. The parietal lobe is separated by from the frontal lobe by the central sulcus, and the central sulcus is sort of an important navigating point in the brain, because there's two gyri there called the precentral gyrus and the postcentral gyrus. Right now we'll talk about the postcentral gyrus, so that comes after the central sulcus, thus post. We call that the somatosensory cortex, and it's all of the touch and pressure information goes there from all the body parts. And so if you, they first recognized that this area of the brain had to do with touch, because if you electrically stimulate the parts there, you might electrically stimulate one part and people will feel tingling in their hand or in their foot or in various parts of their body. The damage will produce a weird thing called contralateral neglect. So if you have a damage in the somatosensory cortex, you might just start like not even recognizing your right leg if you have damage, say, in the left side in the somatosensory cortex. And so you don't try to move your right leg. It may be able to move, but you just don't even try to move it, and you don't recognize it. In fact, if you drew a picture of your body, you would probably draw it as half of your body if you had that contralateral neglect. Here you can see the way that post-central gyrus or the somatosensory cortex looks. And here you have represented on that what we call a homunculus. And the homunculus is the way that the body is represented. So remember, this is all touch sensations. So if you look at this, one of the things you see is that the face is huge. The face and the hands are very, very sensitive to touch, but some parts of the body are not as sensitive to touch. And so you can really see there what the sensitivity is there. I mean, it's quite different. Okay, let's see. Okay, moving along to the temporal lobe. In the temporal lobe is associated largely with hearing, although we'll see later on it's associated with vision as well to a certain extent. But I want you to think right now in terms of hearing. And you can remember that by the word tempo. Tempo of music is, you know, the beat of the music. Okay, so primary auditory cortex is there, and that's where we hear and interpret noises. So as they come in through our ears, they go to the thalamus and then to the temporal lobe there. Damage will produce a cortical blindness, and that is the inability to recognize sounds. Cortical deafness. It's the inability to recognize sounds. So you'll hear sounds, but you won't be able to recognize different people's voices and stuff like that. If you get a tumor there, you start to get visual and auditory hallucinations. And interestingly enough, you've probably heard that people with schizophrenia have a lot of times auditory hallucinations. And when they do, this area of the brain, the temporal lobe, is active. So we know that it has to do with those hallucinations. They're not really hearing voices, but their brain is sort of acting like they're hearing voices. Okay, frontal lobe. The frontal lobe, as I mentioned, we have that central sulcus there, that crack, and then on either side we talked about the post-central gyrus on one side, and on the other side there we have the pre-central gyrus, so before the central sulcus, and that is the motor cortex. It's involved in the initiation of movement. So if I'm going to wave my hand, that is coming from my motor cortex right here in my frontal lobe. And so this is making this hand wave. It's ordering that movement. And then we have this area up here called the prefrontal cortex. And that is a very important area for planning, remembering, attending, interpreting, all the smart stuff we do, making decisions about life, you know, being able to analyze things. It's very important for short-term memory, we'll see. And we see that in a task that I'm going to talk about later in the memory chapter called the delayed response task. When people do get damage up here, and they often do because you can get damage there by hitting your head really hard, it will lead to a kind of social inappropriateness, and it will lead to a problem where you can't change your behavior depending on context. So, you know, I mean, I'm acting professional right now, or sort of trying to, even though I'm in my home. I wouldn't necessarily act this way with my friends or whatever. And so you can imagine not being able to make those changes in acting in socially appropriate ways. And that was what happened to this guy named Phineas Gage, who you probably heard about in intro psych. He got a pole through his head. I don't know why that wax figure has him smiling with a pole through his head, but it does. Anyway, he was a railroad worker. He damaged his, he kind of cut off his prefrontal cortex. And there you saw just, he changed very much in personality. He lived through it miraculously. And that was one of the first ideas we got about the way that the frontal lobe worked. Okay, there's your primary motor cortex there. Here's your central sulcus in the middle, that crack. And of course, the post-central gyrus, which we already talked about in the parietal cortex. Here, the primary motor cortex, it has a homunculus also, and it's laid out in much the same way. We've got great muscular control of our hands, great muscular control of our faces, but other areas don't move so well, or they only move in very restricted ways. For example, your thigh can only move in pretty restricted ways. Not much of the brain is devoted to movement of the thigh, but a lot of it is devoted to the movement of the face and the hands. And this just shows you the left side of the human brain, and then we can see there the somatosensory cortex and the parietal lobe, and then the motor cortex and the frontal lobe there are side by side. So motor and sensory kind of go together there. And you can see, again, we have the parts of the body laid out on each one of those. Well, a long time ago, there were some doctors who had done some work with chimpanzees, and basically what they did is damage their prefrontal cortex and found out that the animals became tamer and they did pretty well. They didn't have sensory and motor problems as long as they didn't get it too far back in the frontal cortex. And then, so some people had the bright idea of let's just take people with schizophrenia and other mental problems and let's just try to damage their prefrontal cortex. And so that was a procedure called the prefrontal lobotomy. It turned out to be a disaster. It caused apathy, lack of motivation, inability to plan, initiate behavior, all kinds of memory problems, flat affect, which means no emotion, lots of loss of social inhibitions, people doing crazy things. And so there were about 40,000 of these done in the United States in the 1940s and 50s. And the Igaz Moniz was the founder of the operation. Actually, one of his patients who got the lobotomy, in fact, shot him. Walter Freeman had popularized it in the US, and he just went to hospital after hospital after hospital and just lobotomized a ton of people, some of which really had no mental disorders at all. He even did children. So it was a really sad point in the history of psychology and psychiatry. Okay, I'm going to quit there and we'll do Objective 6 in the next video. Have a great day and enjoy your day.